Hi, everyone. So, this is in continuation to the discussion for the smart contracts, and particularly, we would be touch basing on the aspect of the classification first. Once we understand the classification, we can always through the understanding of 2D, 3D, 4D till 8D. So, the dimensions have to be understood with the deployment of the quantum understanding. So, there has been a lot of emphasis in recent past, and that is one reality most of the stakeholders need to understand. And that reality is human capacity building as to the understanding of what ICT is all about. So, when we talk about the ICT understanding of structural and the functional relationship for the structure alignment, that is tagged under G16 B15 slash 00. Then for the quantum algorithm, so we will focus on the quantum part more today for this session. So quantum algorithm based on quantum optimization, quantum Fouriers, and Handamad transforms, that is G0 6 and 10 slash 60. Um, Knowledge based neural networks, that is logical representation of the neural network, that is G naught 6N3 slash 042. Combination of network is G naught 6N3 slash 045, that is combination of networks. Generative network is G naught 6N3 slash 0475. So let's deep dive into the quantum understanding. So, uh, if I have to select one of the published data set, it would be okay. This looks good. Solving problems. Okay. The graph matching. So, one needs to understand what can be utilized for the matching purpose. Look into G0 6V30 slash 1988. Um, Then we look into the hardware and software architectures, which is adapted for the image and video understanding under the classification of G0 6V10 slash 94. For the nanotech part of the information processing, storage and transmission, it's B82Y 10 slash 00. Okay, so I'll be talking a little bit about the background here, and then we'll try and understand QUBO, that is QUBO, which stands for Quadratic Unconstrained Binary Optimization, and how QUBO problem is matched to the quantum processor via the modules and the submodules, which in which Impala is a kind of a core to have the analysis in a proper fashion, because a lot of input data set has to be the right data set, and for that uh, QUBO problem to be casted, that is quadratic unconstrained binary optimization. Let's understand what is Turing machine. So Turing machine is a computing module submodules which was actually described in the year 1936. So that's way back in the timeline. So 1936 by Alan Turing. So it's by his name, and that's why I have my algorithm in my name. So this theoretical computing system, which is hardware software both. So the Turing machine was simulating any other Turing machine and was called as UTM. UTM here stands for Universal Turing Machine, and there's another term which is Church Turing thesis. Now, this thesis states that any practical computing model can either have an equivalent or subset capability of UTM, that is, Universal Turing Machine. Now, when we talk about another very important term here is UQC. UQC stands for Universal Quantum Computer. Now, this quantum computer is any physical system which, so we are talking about a physical system here, which has a communication network and can harness one or more quantum effects to perform a computation with the input data set. And the quantum computer is effectively computing or simulating any other quantum computer that is called as UQC, that is Universal Quantum Computer. So we went back on the timeline of 1936. Now we're coming to the timeline of 1981, which talks about, I mean, most of the folks really we share this data set on, earlier it was known as Twitter, now it's X. So this characterization of Richard Freeman, he proposed the quantum computers in the year 1981, which could be used to resolve computational problems more efficiently than the UTM, and therefore invalidated the Church Turing thesis. So the point here is, from time to time on the timeline, what happens at what happens at any given point of time is a lot of problem statements are coexisting, and the folks and the understanding of the alignment of the data set is able to, there are two ways. Either you are competing with the other algorithms, which we don't want to do, we are in a parallel situation, which is there is no intersection between the two parties or the multiple parties, paving a way out for the 6G, 7G, 8G, and the like, because the generative technologies per se, although most of the stakeholders have no cognizance of it, but they are the stakeholders because they are responsible to sign those physical papers at ease. Okay, so here Freeman said that quantum computer could be used to simulate certain other quantum systems, allowing exponentially faster calculation of certain properties. So rather than calculation, I like the word evaluation. Sometimes I use the word calculation, but let's take it evaluation for now. Um, what we are trying to do is using the UTM, whether we can take a part of the 1936 research and put it into practice in 2025 and beyond. So that is something we are doing some hypothesis with the right input data set, because the reality here is there are two aspects. One is the environmental data set, which you can easily take through these devices, which is handheld, and the other is a historical data set. And for the historical data set, it's always good go it's a good process to go back to the historical data set and use that knowledge and work around your quantum stuff in terms of the algos you're developing using the machine learning models. And probably I would say, um, develop your own models, which is very simple in practice when you understand the nuance of what blockchain is all about. Okay, what is happening here? Let's. So let's, if we have to take a flow diagram, let's for the time being, the first step is optimization. First step is the optimization, second is the mapping, and third is the evolution. Uh, Put this into practice in your quantum understanding of the flow diagram and look for your own self how it works for you people. So I'll be doing my own coding at my end after this session, And I think we are good for this session. I discussed a lot of uh, timelines. I discussed some timelines. I discussed the tagging part. I discussed the optimization part. Look into it and see how it works for you. Thank you for watching this out. Have a great day ahead.